Welcome. We've spent decades building systems that follow explicit instructions with precision and scale. We've mastered automation. But the next paradigm shift is already here, moving beyond automation to autonomy. We are transitioning from systems that execute predefined tasks to systems that understand and pursue high-level goals. This is the era of agentic AI. In this deep dive, we won't just define what an agent is, we'll dissect the architectural patterns, operational challenges, and system design principles required to build, deploy, and manage them effectively in production. So, what fundamentally separates an agent from a sophisticated script or a standard machine learning model? It's not just about intelligence, it's about agency. There are three pillars to this. First, goal orientation. An agent is given a high-level objective, not a list of steps. For example, instead of execute these API calls in this order, the goal is procure the most cost-effective compute resources for this workload. Second, autonomy. The agent has the freedom to devise and execute its own plan to achieve that goal. It can select tools, sequence actions, and adapt its strategy without human intervention. And third, a continuous perception action loop. The agent constantly observes its environment, system metrics, API responses, logs, and uses that perception to inform its next action. This loop is what allows it to handle novelty and unexpected conditions, a critical departure from brittle, hard-coded logic. This isn't just a chatbot, it's a dynamic, self-directed entity operating within a defined digital environment. Building a single agent is a challenge. Building a resilient, scalable system of agents requires deliberate architectural choices. Let's explore a few dominant patterns. First, the hierarchical multi-agent system. Here, a primary orchestrator agent decomposes a complex goal, like deploy a new microservice, into subtasks. It then delegates these tasks, like provision infrastructure, run CI/CD pipeline, and perform security scan, to specialized subordinate agents. This mirrors a well-structured engineering team and promotes modularity and separation of concerns. Another pattern is the agent as a tool model. Instead of having one monolithic agent, you equip a primary agent with a library of other agents it can invoke, much like a function call. This is powerful for tasks requiring diverse capabilities, such as combining a code-writing agent with a database querying agent. Crucially, all these patterns depend on robust state and memory management. An agent needs long-term memory to learn from past actions, and short-term or contextual memory to track its current plan. Architecturally, this often translates to using vector databases for semantic memory and fast key-value stores like Redis for managing session state. The choice here directly impacts the agent's coherence and effectiveness. As architects and DevOps professionals, our immediate question should be, how do we debug this? Agentic systems introduce a new class of operational challenges. Their non-determinism means that given the same goal, an agent might choose a different path each time based on subtle environmental cues. This makes traditional debugging and root cause analysis incredibly difficult. We must shift our focus from monitoring execution paths to monitoring behaviors and outcomes. Are the agent's actions aligning with its intended goal? Is it entering unexpected loops or failure modes? This requires a new layer of observability. We need to log not just actions, but the agent's intent and reasoning at each step of its planning process. Think of it as logging the why behind the what. Furthermore, control is paramount. We need robust guardrails and fail-safe mechanisms. This includes cost-capping agents that can interact with cloud billing APIs, permission sandboxing to limit the blast radius of a misbehaving agent, and, critically, a human-in-the-loop approval step for high-stakes actions. Without this operational rigor, we risk creating systems that are not just powerful, but also dangerously unpredictable. We've seen that agentic AI is far more than a clever language model wrapper. It's a fundamental shift in system design, demanding new architectural patterns and a renewed focus on operational safety. So, what is the tangible takeaway? Start small. Don't try to build a fully autonomous fleet of agents on day one. Identify a well-scoped, high-value problem with clear success metrics and a low tolerance for error. A prime candidate could be an agent that intelligently automates incident response runbooks or optimizes resource allocation in a development environment. Build your observability and control plane first. Before you grant an agent any significant autonomy, ensure you have the tools to understand its reasoning and the levers to intervene when necessary. The future isn't about replacing engineers with agents, it's about empowering them with autonomous tools that can handle complexity at a scale humans cannot. The work